Hello everyone. In a couple of months' time from now, various institutes across the country are going to conduct their exams and interviews for the selection of PhD students. Here also in IIT Kharagpur, we are going to do the same. And so I thought that it will be a good time now if I share some tips with you all so that you will have sufficient time in your hand to incorporate some of these tips into your preparation, into your work plan, identify some of the gaps in your preparation and fill them accordingly. But before going forward, for the benefit of those who may not be familiar with me, let me introduce myself. I'm a faculty member in the Mechanical Engineering Department of IIT Kharagpur. Before this, I was an undergraduate student again here at IIT Kharagpur in the Mechanical Engineering Department, and I was also a PhD student. So I have experience from both sides of the table as an interviewee and as an interviewer. In fact, over the past 5-6 years, I have sat in approximately a dozen interview panels. But my experience is limited to the design specialization within Mechanical Engineering Department. Despite this narrow specialization, I think some of the tips that I'm going to share will be generally applicable across the different IITs, across the different departments, and more generally to other places also like the central universities and the state universities. There will be some notable differences, but I think the general tips will be beneficial to all of you. Okay, so for the interview part, the first question that we generally ask is, please introduce yourself, give us a little background starting from your undergraduate days. In some cases, we may also ask you about your results starting from the 10th boards. Now, we have all of this data in our hands. Despite that, we ask this question just that you feel a little bit less nervous. You can get over your initial jitters. Because we are all human, we feel a little bit nervous when facing an interview panel. And believe it or not, we always want to extract the best out of the candidate. Okay, so the PhD interview, so this is the first tip or an inside peek into the thought process that goes into a PhD interview that I'll be sharing with you, is that it's not an elimination procedure, it's a proper selection procedure. So have a little hurt in knowing this. Okay, so we want to extract the best out of you. So after this initial some kind of a small talk is over, we'll ask about your broad interests and also about your specific research interests. Now for broad interests, for example, if you're in mechanical engineering, you may say some things like solid mechanics, fluid mechanics, acoustics, thermodynamics. And for specific research interests, you can say, so usually what happens is that the students say something along the lines of their master's level project. And that's fine, but there is a little bit of a thing which you must be careful about. It is that sometimes I have noticed that the candidates, when they are stating this kind of a research interest, they state it in such a fashion that it appears that they are not willing to work on anything else. Okay, so that's rather unfortunate. So you should present your research interest in such a fashion that it shows that you have some research interest based on what you have done during your master's, but at the same time, you should also evince some kind of an open-mindedness towards pursuing some other projects. Because trust me, it may not always be possible that the place where you are interviewing may be having a research program or a project with any of the professors which is in sync with your master's level project. Okay, so please keep that in mind. So please show some kind of an open-mindedness about it. Let me go on to the actual interview, the question answer type of things. So before I share with you any tips, I want you to understand a little bit about the philosophy behind us, the interviewers, asking you some technical questions. Okay, so it's something like this, that one may always question that despite the written examination, despite all the academic records that you have, all the examinations that you have gone through since your undergraduate days, why are we making such a big fuss about asking these questions during the interview? Okay, so it's something like this, that you say during PhD, you are not going to tackle some kind of a known problem. By its very definition, your work will be on some kind of an unknown problem whose answer is not predetermined. Okay, after you have solved something, you do not have a textbook, the back of a textbook where you can actually look at the answer or to match your answer. So what do? well you think about what you have found out, your solution. Okay, you try to gauge the physical meaningfulness of your solution and try to think that perhaps if you had taken some kind of other solution methodology, would you perhaps have arrived at different sort of answer? So this kind of a juxtaposition of different ideas, thinking in a very broad-minded way about, in a broad-minded as well as in a very dispassionate way about your own solution strategies, that is what is required. Okay, and that requires some kind of academic maturity, and it is this academic maturity, whether you have it or not, that is something that we wish to gain an insight into by asking you these technical questions. So on this note, what I would say is that I've always, I've oftentimes seen this happening to many of the students, many of the candidates, that when they come for the interview, when we ask them some question, they do not express themselves fully. Maybe it is a little bit out of nervousness, or maybe they have gotten some kind of an advice that they should be very, very precise in their answers. But please note that precision in your answers is not at odds with the brevity of your answer. You can be precise but long in your answers. You can be elaborate in your answers but still be precise. Okay, so through the interview, we actually want to gain an insight into your thought process. Okay, this is very, very important. It has happened many a time that the student may not be actually arriving at the correct answer or the correct solution that we are asking him to solve or answer, but just by giving us a proper glimpse into his thought process, into his or her thought process, we have gone on to select those candidates. Okay, because we like the way that he or she is trying to think and work his way into the problem. Okay, that kind of a long form, very, very analytical thinking, when he shows plus at the same time it also shows that he has a good communication skill, because when this student is actually selected and goes on to work with a particular professor on a regular basis, he has to discuss things with the professor. So unless he has this ability to communicate what he's thinking, what he or she is thinking, then how will the professor be able to work with him? Okay, so this is very, very important, and this is something which you have a great opportunity to show during the interview, and you must take full advantage of this opportunity. Okay, so the interview is actually an opportunity for you to display this ability that you may have in front of the professors. Okay, if you succeed in this, a lot of your work is actually done. Okay, let me give you a very specific example. So since I am from a mechanical engineering background, I'll try to give an example which will be generally from this, quite important from this mechanical sciences. So it will be beneficial for students of mechanical engineering, civil engineering, aerospace, maybe even naval architecture. So it's a very popular question. Suppose we ask you, what is the Reynolds number? Okay, now many of you will jump at this question and say that it is the ratio of inertial forces to viscous forces. Okay, great. So our next question perhaps will be something like, okay, tell us the formula of the Reynolds number. Now this may seem apparently like a very information-based question, and perhaps an undergraduate student who has just learned fluid mechanics in his previous semester, he may immediately say something like Re, the Reynolds number, is equal to rho Vd by mu. But we expect a little bit of more maturity from a potential PhD candidate. Okay, so some of you who are a little bit more sophisticated would have already detected where I'm going with this. You see, during the interview, if you face such a situation, don't immediately jump to the actual formula that you may know. Think about it, pause a little bit, and this actually goes beyond this very particular example of Reynolds number that I'm saying. This is just a specific case, just to concretize our thought process, that perhaps you can ask back to the interviewer that whether he or she is thinking, to the professor actually, you ask, are you perhaps thinking of an internal flow or an external flow? The moment you ask back to the interviewer a question like this, then it shows that you have some academic maturity. Okay, you will immediately see some kind of a spark enlightening in the eyes of the professor. Okay, he will immediately think, okay, this guy is not any run-of-the-mill candidate. Okay, there is something special about him or her, and we need to prod him, we need to extract the best out of him. Okay, So after he or she says, so this will actually encourage a little bit of a discussion, and you as an interviewee have this ability and power in your hand to direct or orient the direction of your own interview. Okay, so when you know something, stay on it, discuss things around it. Okay, it will help you to highlight your own strengths. This is one of the, like, if you have to pick one big tip from this entire video, let this be, okay, that you can orient the direction of your own interview. It can so happen that the interviewer next asks you a question again on the Reynolds number, but based something on your research interests. Now, many students across various institutes, they're working on microfluidics, microscale flows, low Reynolds number flows. So be prepared to face some kind of a googly question. Okay, so perhaps you may be asked something like, you have a flow where the Reynolds number is small, but not so small that it is much less than 1. Despite that, do you know of a situation where the Reynolds number is perhaps larger than 1, but still we can drop the nonlinear terms from the left hand side of the Navier-Stokes equation? Okay, so the answer of course is yes, that in lubrication type of flows where the thickness of the confinement is much smaller than the lateral length scale, so the H by L ratio is so very small that it actually helps us to drop the terms, the nonlinear terms from the Navier-Stokes equation. Okay, so this is the very common lubrication approximation. So things like this. Okay, on the counter side, perhaps you have worked on your masters on microscale flows, and the interviewer wants to maybe broaden or maybe wants to prod whether you have a broader understanding of fluid mechanics. And so staying on the topic of Reynolds number only, maybe he can completely turn the table and ask you something regarding large Reynolds number. So maybe you're more familiar with small Reynolds number, maybe he can ask you something more large Reynolds number. So we go into maybe a question from boundary layer theory. Okay, so maybe you'll be asked something on the assumptions of boundary layer theory. Maybe you can be asked something on the relative length scales involved for hydrodynamic boundary layer and the thermal boundary layer. So a lot of the questions can follow along from there. Okay, and during your preparation, I would suggest that try to get this kind of very broad perspective of what you have studied from different kinds of subjects. Okay, so try to connect the various things, the Reynolds number, the Prandtl number, the Pecklin number. So all these non-dimensional numbers, they are not just little definitions stacked up in a table, okay, somewhere in your textbook. They are actually gateways into connecting the different strands of learnings that you have had in your undergraduate and your masters. Okay, so enough of fluid mechanics. I personally don't teach fluid mechanics anymore. I did it from 2016 to 2018. Let me go on to solid mechanics, okay? And I have enlisted some questions. Let me share with you some of those. So just to give you an example, okay? So if you're from mechanical engineering, civil engineering, aerospace, maybe naval architecture again, you'll find some benefit into this. Oh, by the way, the Reynolds number, the chemical engineering guys, certainly. Okay, I forgot to mention chemical engineering, I think. Okay, for solid mechanics. Now, one of my personal favorite questions is to ask the candidate about the concept of the traction vector, and invariably I will see that the candidate doesn't know this. Okay, so this is perhaps a weakness of some of the educational institutes that they have been through. In certain places they don't teach all these things, but especially if you are from a good institute like an NIT or maybe another IIT, there is absolutely no excuse for you not to know about traction. Okay, then you be careful. Okay, if you're from a good institute, you should know all of these things. Okay, so if you don't know about traction, go and study it. Okay, the traction vectors, it's an absolutely fundamental concept in solid mechanics. Next, so stress equilibrium equations. It's a very common question which in one place or another you will invariably face, but since you're at the PhD level now, at the interview level of a PhD candidate, so it's not just saying things like del sigma xx, del x plus del sigma xy, del y plus all those things. I mean, you know all these things, the stress equilibrium equations. But maybe you'll be asked something like, under what conditions will you obtain the stress equilibrium equations from the Cauchy's equation of motion? Okay, the Cauchy's equation of motion is just general equation of motion, which is applicable even in fluid mechanics, solid mechanics. Okay, and especially if you are saying that your research interest is in fluid-solid interaction kind of problems, then you should know all of these things very well. Okay, so how do you obtain the stress equilibrium equations? Basically, the divergence of sigma from the Cauchy's equation of motion. And these kinds of questions are pregnant with possibilities of entire discussions. Okay, you can have hours and hours of discussion on these things. So brush up on these things. There can be a big googly question, okay, in solid mechanics, which is to do with incompressible solids. Okay, it's a fascinating topic. If you have gone through a good textbook on elasticity, you will have invariably learned this. Okay, if you don't know, learn it. Okay, it's a fascinating topic, very, very interesting, incompressible solids. So many of you are familiar with incompressible fluid or incompressible flow, but there is such a thing as incompressible solid also. Okay, so brush up on that. Next is regarding boundary conditions. So this is an extremely important topic for actual practical problems, and you should be very clear on things like continuity of displacement, continuity of traction, and how they may be applied for particular cases. So for example, we may give you two different materials which are stacked up like that. So what happens at this interface? Okay, so if you don't know this, again, take up a good book on elasticity, brush up on the fundamentals, you should be good. Okay, it's not difficult, you just need to have a very clear visualization and understanding of the fundamentals. Next, I have often seen, like, there is not a single interview that I have I've sat on where there's a number of candidates who have said that their research interest is on composite materials. Okay, every time it happens. And I'm sure many of you viewing this video may already be interested in composite materials. So I thought I'll just point it out that, fine, it is good that you are interested in such a hot topic, but please make sure that if you say that your research interest is in composite materials or mechanics of composites, that you are absolutely clear with the material symmetries. Okay, so the constitutive behavior, like transversely isotropic, orthotropic, and whatnot. So you have a very clear visualization of these kinds of material symmetries. Okay, and not just saying things like, okay, there are two independent material constants or four independent material constants. Not just that. Okay, so anybody can mug up those things, but a proper visualization of the symmetries involved. Okay, because you will be invariably asked questions on those things. Next. Sometimes I have myself asked questions like this, that suppose some student says that, okay, divergence of sigma, the stress equilibrium equations, or divergence of sigma plus rho b, the body force per unit volume, equal to 0, that's the stress equilibrium equation. I'll ask something like, okay, what is the nature of this equation? Is it a vector equation, or what kind is a scalar equation? What kind of an equation it is? Okay, and like, very surprisingly, I have found, and very unfortunately also, that students sometimes fumble on this. Okay, they know that the stress is a second order tensor, they know this very well, but despite that, sometimes they just falter. Okay, so please again brush up on it. Very important warning, so to say, is that I've often seen that sometimes when students don't know something to some obscure solid mechanics question, they just come up with, I don't know why they say this, sometimes they just randomly say compatibility equations. Okay, please do not do this. Okay, so compatibility equation is a very specific thing. It is, I believe it is one of the hardest things to understand. I'm sure many other professors will also agree. There's a whole richness to it which you really need to appreciate well. So unless you have a very clear idea of compatibility equations, don't just randomly say okay. And on that note, brush up what the compatibility equations are. Right. Next, there's a very popular question since I do a little bit of work regarding buckling. Sometimes people ask this question. So it's a very old question. What's the difference between buckling and bending? Okay, very classical question for an interview. So there you have it now. Go and study it. Okay, what's the difference? Okay, so and generally, if your research interest has something to do with buckling, please make sure that you understand buckling more generally as a form of instability and not just that limited concept of Euler buckling which you have only studied in your undergraduate days. Okay, so when you open up your mind to this possibility that buckling is a general form of or is just one instance of a general mechanical instability, then you open your mind up to the possibility of wrinkling that may happen in plates. So there's a whole fascinating world out there. Please do take a look into that also. Okay, so especially if you have worked on plates and things like that, we would expect you to know things like this. All right. Now, these are some of the very general tips I thought that I'll share with you. Probably it will be of more benefit to the non-circuital branches. The computer science, electrical, electronics guys will not find too much use of this. But I hope that through these questions, especially that earlier discussion regarding the Reynolds number thing, I have given you some glimpse about the kind of twists and turns that professors present you with during the interview. And please note that during the course of the interview, if you actually see that the professor or the interview panel is asking you some twisting type of questions, please do not feel discouraged. It is actually good that they are asking you this, because they have gone past that stage where they are just asking you information-based questions, which just any good hardworking student can answer. Now they are going into the realm of questions which are actually prodding your thinking process. So they're trying to extract that special something out of you. So feel very encouraged that it is going well. Okay, and final note, when you're faced with a question and you feel that you don't know the answer to it, please be very honest about it and say that you don't know. Okay, it is much better that way. The bad thing about you beating about the bush when you don't know the answer is that, first of all, two things can happen. Two kinds of impressions can create. First is that you have not even understood the question. That is why you are beating about the bush. The second is that maybe you have understood the question, but you're beating about the bush because you don't have a proper academic integrity. Okay, you're just trying to bluff your way out of it. So either way, it creates a very bad impression on you. Okay, and trust me, especially the senior professors, they have seen all varieties of answers from students when they don't know the answer. They can very immediately they can pick up that you're trying to bluff your way out of it. Okay, so please don't do this. If you don't know, just say that you don't know, or maybe that you have just forgotten. They will ask you a different question and no harm done. Okay, not much harm done. All right, so that's all about it. I'm sure I'm missing out many millions of other tips, but you are all intelligent guys. Through this little brainstorming thing, I'm sure you can pick up the kind of thought process that goes into the interview session. And I personally am actually looking forward to recruiting a couple of PhD students this summer. So wouldn't it be just wonderful that someone out there watching this video actually ends up being my own student, my own PhD student? That would be just wonderful. So on that positive, hopeful note, I will end this video. Thank you very much and all the very, very best.